Here are solutions to quiz number 1 for ECE 321. The first problem is to give n equations to solve for n unknown voltages. You don't have to solve, just write the equations. So the easy ones to do would be the output of the op amp. At node 3, I can't write the node equation because I have no idea what the current is out of the op amp. Likewise at node 5, I don't know what that current is. The node equations at the output is actually V plus equals V minus. So know right away that V1 equals V6, V4 equals V7. Now write the other equations. At node 1, the current left plus the current right equals 0. Gives you this equation. At node 2, the current left, current right, current up equals 0. That's your V2 minus V1 over 2K, plus V2 minus V3 over 3K, plus V2 minus V5 over 10K equals 0. Node 3 I can't write, and I already wrote it. Node 4, current left, V4 minus V3 over 4K, plus V4 minus V5 over 5K equals 0, and so on. So these are your 7 equations, 7 unknowns. Problem 2. Find V3 as a function of A, B, C, D. And to do that, do it in 2 steps. V1 is an inverting amplifier. Its gain is R over 1K times A, actually minus R over 1K times A, minus R over 2K times B. V2, this is X, and this is a weighted average. So it's going to be 2 times C plus D. Add the coefficients, I get 3. So this is 2/3 C plus 1/3 D. Times 1 plus the ratio. 1 plus R over 1K. So that'll be V2 times 1 plus R over 1K. Over here, this is an instrumentation amplifier. The gain is R over 1K times V1 minus V2. So these are the 3 equations. Substitute, I'll have V3 in terms of A, B, C, D. Problem 3. Come up with a circuit so that the gain is 1.3A plus 2.5B plus 3.7C. Now there's a whole bunch of solutions. One of them is to form a weighted average. I'm going to use 3 resistors in parallel, and to weight it, I'll pick a number like 10K. The weighting on A is 10K over 1.3. 10K divided by the weighting on B, 10K divided by the weighting on C, gives you X. The average is 0, like if all these are 1 volt, X is 1 volt. So divide by the sum of the coefficients, 7.5. To clear the denominator, add an amplifier with a gain of 7.5. There's other solutions. Problem 4. Change the sign on B, and there's a couple ways to do it. Here what I'm going to do is using inverting amplifiers. So here I have a gain of negative times negative cancels. This is a gain of 1.3 minus 1.3A minus 3.7B. Change the sign with a gain of minus 1. B has a gain of minus 2.5. So here's one solution. There are others. Problem 5. Find the voltages for this circuit. So I know that V plus equals V minus, so this is 1.5 volts. So V3 is 1.5 volts. This is a voltage divider. The output is 1K over 1K plus R times V2, or going backwards, V2 is 1 plus R over 1K. So for me, that'll be, if this is 1.5 volts, this is 3.47 volts. V1 is V2 plus 0.7, 4.1 volts. To find the current is 3.47 over 8 plus 3.47 over R plus 1K. That's I5. Turns out that's 428 milliamps. I4, this is the emitter, that's the base. IB is the emitter current divided by beta plus 1. Beta is 25, so take this divided by 26, that's the base current. The last problem is a push-pull amplifier in current mode. If I have this circuit, V plus equals V minus, so here's 1.5 volts. This is 1.5 volts. These resistors set the current. 1.5 divided by 10 in parallel with R gives you 151 milliamps. So that's I5. Again, that's the emitter current divided by beta plus 1, divided by 26. They get our I4, 5.8 milliamps. Then the voltages. This is an LED. This is 1.45 volts. This is 1.5 plus 1.9, 3.4 volts. Plus 0.7 for the diode, 4.1 volts. So that's quiz number 1 for ECE 321.